Hey guys, Alexander Williamson here with the secret history living inside of your aquarium, my aquarium. Today we're going to be talking about the world as an aquarium, and we're going to bring it right back to your aquarium again. So, the first thing I want to show you before I tell you about this epic story that envelops from Africa all the way around the world and keeps plants living and life going, and it also kills things. This is a pretty crazy ecosystem around the world that's a model exactly for how things work in your tank, and a cool story. And I hope I can teach you something about how your plants use energy, and maybe a little bit about how your fish use energy as well. So, take a look at this little drawing I've got here. This is ATP, and this is the chemical currency of energy in the biological world. Now, this molecule, this whole thing, is how every living thing, from the weird worms that live in vents down in sulfuric waters at 400 degrees or whatever it is, survive and have energy coming out of their mitochondria in their cells. That's the little energy makers in cells, the powerhouse, if you will, to penguins, to you, me, plants, fungus, everything. Every living organism uses this same molecule. It's that crazy, and it's also a building block, in part, of just about everything you need for a plant to grow and thus life to be sustained. Your fish use this as energy as well, so they need all these elements. So when you take a close look, we're not going to get into any crazy chemistry because organic chemistry gets really sticky really quicky, and I don't want to bore you if you didn't come for that, if you came for a story. But I got to go over this quickly. So, in this molecule, do you notice anything that looks familiar to fish keeping? Look at the elements. So we've got hydrogen, we've got oxygen, that's H2O. I mean, that isn't right there. Well, you can make it out of those pieces, right? Okay. We've got phosphorus. Now you need phosphates. This is a phosphate here. There's lots of different phosphates. They're salts made with phosphorus chains as the main ingredient or base. Sugars, which also are energy in your plants, that are burned quickly, they are part of this ribose, which is riboflavin, different things down the line. You've probably heard similar names, but we've got hydrogen, oxygen, forming a nice structure there. And then up here, this is the part that's part of DNA. This is adenine, and you may have heard of that, and guanine, and the ATG, the Gattaca of DNA, if you want to borrow the movie. There are 4 types of DNA markers, A, T, C, and G, and this is the basis of one of them. So, in here we have the reflection of my windows, sorry guys, and we have nitrogen, more hydrogen, and if you look carefully right in here, the corner of all these rings are carbon. Carbon, which every life form on Earth is based on yet again. Okay, so take all that info and put it in your minds for now, okay? So now I'm going to tell you the biggest story on Earth as far as life goes, ecosystem goes. So some cool trivia you can tell your friends, and plus I think it's just super interesting. So follow me along this rabbit trail. So where do we start? Let's start in the Bodel Depression of Africa. I need to stop pointing at the screen because it just focuses on my finger and my hands and my Halloween nail polish. So let's start in the Bodel Depression in Chad, which is in Africa, if you didn't know. It's in the center of Africa. It's in north central Africa near the equator, and it is hot. It is the Sahara Desert. It is one of the hottest places on Earth, with, you know, Iran, the Gobi Desert, and Death Valley in California being its main rivals. But super, super hot. No fish there, except for in one or two rivers, and maybe a couple oases, but that's not why we're there. We're there to talk about the dust, the sand that's blown around into sandstorms, these crazy sandstorms that go 10,000, 20,000, 30,000 feet into the sky, up into the atmosphere, and literally circle the globe. But most of the particles are a little heavier than circling the globe, and they get kicked around and fly and flutter 2,600 kilometers into the Amazon rainforest. Now, what is this dust made out of? Predominantly carbon, hydrogen, nitrogen, silica, but mostly 56% phosphorus. Now, in that ATP molecule, do any of those things sound familiar? And then we have nitrogen and we have oxygen in the atmosphere. 70% of the atmosphere is nitrogen, which is not absorbable by plants, unfortunately, just chilling in the atmosphere. Now, in the form of CO2, it can take that out of the atmosphere, and it can take oxygen out of the atmosphere, and plants need oxygen to live. They just don't breathe it like we do. They can break it down at the cellular level, because all cells need to respire, and plants use oxygen. So, how do they do that? Pretty amazing. So that's one amazing thing, is that they're just assembling atomic levels of things. Like, they're taking things down to an atomic level, from molecules, from dirt, from dust, from water, and spitting it back out into its constituent parts and different forms. We do this too in our body. It's near, dare I say, a miracle. So, the Bodell Depression, dust comes over. It goes into the upper atmosphere. As it's flying around, swirling in the upper atmosphere, what does it do? Those pieces of dust, they start to gather condensation on them. Water, H2O. And if you remember what I'm saying, the air has the nitrogen and the oxygen. And now we got the H2O that's swirling around as water vapor, moisture. As it comes over the cooler ocean, these particles gather, and as they hit the coast, they rise up. The warm air rises and the cool air settles of the ocean, cooling down off of the continent, and we get these massive lightning and thunderstorms. And if you saw my last video on big picture stuff, lightning and thunder and elements, you will know that, as I said, nitrogen cannot be processed by plants. It needs to be turned into nitrates or nitrites, other nitrogen compounds. So, how do you do that? Well, conveniently, lightning or a ton of energy, like a nuclear bomb. But let's not do that to fertilize our gardens. I think it would have some other side effects. But lightning heats up to 50,000 degrees, hotter than the surface of the sun, pretty hot. I've had my run-in with lightning, so I've been very fascinated by it, and that's kind of what's brought me back to this. How does lightning play a role in the fish tank? It's crazy that it does, and Africa does, and okay, so lightning hits those nitrogen atoms, hits the other elemental atoms, and turns into nitrates and phosphates, and then that gets caught in the particular, and this is an odd fact, but rain does not fall unless it has a speck of dust at the center. So same with snow, like a snowflake, it needs something, even if it's a small molecule of something, it needs something to form around, a nucleus. And that is how a raindrop starts. Now, also oddly, these center things that could be the dust from the same desert, some of it gets caught up in this crazy lightning storm thing, nitrates get caught up in it, and it moves across the ocean just because of the way the world works. This gets really complicated. There's something called the Coriolis effect, which causes things in the northern hemisphere to spin this way and things in the southern hemisphere to spin this way, and they move opposite ways, That's why hurricanes come from the coast of Africa and slam into the Caribbean and the USA every year, and that's why typhoons do the same thing, and why weather patterns go the other way in the southern hemisphere generally. So we won't get too much into that. It doesn't have to do with plants a ton. But all your hurricanes start because of the lightning. And that is because they start updrafts of the hot and cold currents. They get all of these chunks of ice and dust into the upper atmosphere. These things are hitting each other. They're causing electricity and they're spinning around, and it's this turbulent, crazy, energy-packed cell of clouds, and it's carrying all this life-giving nutrients. Now, of that, 150 million tons is blown every year, over to North and South America, Central America. So, a satellite put up by NASA called Calypso has measured that 26,000 kilometers or 1,600 miles, that 43 million tons of that falls in the Amazon. How much gets washed out of the Amazon every year? 41 million tons of phosphorus out into the sea, back to swirl around, back to evaporate up, and to settle in the thunderous wet season that comes once in a blue moon of flash flooding in the Sahara. So, kind of cool that you could not have plants without phosphorus, potassium. Potassium comes in other ways. We'll talk about that in another video. Nitrogen, oxygen, and hydrogen. And so if you look at any good fertilizer, you're going to see that it has phosphates, nitrates, and that it has, some trace chemicals of magnesium, other trace chemicals, iron, things like that plants will need also. Now, those chemicals are also found because dust is made out of rocks falling on the atmosphere. But surely not everything is from dust in the Amazon. No. A lot of that washes out of the Andean mountains down into the rainforest. And then another 27.7 million tons, and this is British or metric tons, I guess. It's tons with T-O-N-N-E-S. I might be wrong on the British part. Sorry guys if I am. But that kind of ton, which is bigger than an American ton, it's like a Texas ton, falls 27.7 to be exact, falls on the Caribbean and Florida and the Gulf Coast. Now a lot of that falls into the water, but the rest fertilizes those islands as well. The same islands that are going to get blasted by hurricanes, the same islands that have guppies and endlers, and Venezuela and Togo and Trinidad, or Tobago and Trinidad, and off the coast of Venezuela. It's really a beautiful circle, and it's the entire world encompassing this circle. It's incredible. So in the Congo, that lightning strike also starts fires, which puts carbon into the air. Carbon being another thing your plants absolutely need in the form of either CO2 or just carbon that they can reassemble. And yet again, that's carried over. But this time in Venezuela, there is a place off the coast of Venezuela in this marshy swamp and off the coast that they get tied. It might be the most lightning. It depends on how you count lightning strikes, if hitting the ground positive or negative. But nevertheless, the two biggest places are in Central Africa and in Venezuela. These two places that are mysteriously linked by this trade through the ocean and then through the atmosphere. And this is how one of the millions of ways that everything is connected in the world, how one thing can cause an effect in another thing. Now, I'm not saying, I shouldn't say everything is connected, but many things are. And you wouldn't think of it until you studied it, until you got a satellite at this point in history and you could follow a cloud of dust and you could see with a laser what the density of that air was, of that dust, You can see where it fell. It's really pretty cool. So now, why is phosphorus important to your plants? That's because it is what builds plant cell walls. In humans, it helps form bones because it binds calcium. And it is also needed for the ATP that I showed you, the DNA and RNA, and most importantly, it limits the growth in a cell. And that can be good or bad, okay? So if you need your plants to grow quickly, you want phosphorus, but if you have too much, they get poisoned by it, and they can grow too quickly. They can get these yellow spots from not having enough. They can get these brown spots from having too much. It's almost like cancer when cells grow too much, and it can also cause algae to grow and then choke it out. So it's all this fine balance that you'll learn as you keep plants in your aquarium. It's all a fine balance to dial in, and that's why there's some great products out there. Whether you want to use C-Chems or Easy Green or API or ADA, I personally use Easy Green from Aquarium Co-op if I'm not worried about my plant load. That has nitrogen, phosphorus, everything but iron in it, but a low amount of phosphorus in it. And I just do a couple pumps of that. That works for most people's aquarium, plus you want to buy a little iron. I've started using, however, ADA in my very heavily loaded aquariums, and I'm using Brighty Green, which has everything but the nitrates and nitrites in it, and it doesn't, excuse me, I just hiccuped. It doesn't have one more element, which is, I'll get back to that later. I'm sorry, guys. I just had a pause in my brain. But the story is that it doesn't cause more nitrogen, which nitrites, that's what the end result, the creation of when your fish go poop, they make ammonia, and they make this other waste, and then that goes into your bacteria, your good bacteria, that turns it into nitrites, which then goes into another type of bacteria, and then it turns it into nitrates, which your plants then absorb and love and grow, and they need the carbon from the waste. They need the carbon from either CO2 or carbon in the soil, in root tabs, in active dirt substrate, however it may be. But these are the same exact forces that are all over the world, and I just think that that is pretty darn sweet. Now, the other thing is that the lightning that splits on the coast of South America, that splits the nitrogen, it causes more nitrogen to be made than even the rainforest can handle, because there's lots of lightning over the rainforest too. So most of this gets washed away. And during the wet season, unfortunately, the Amazon is known to not have the best quality soil in some areas. Okay? They've had trouble there. And there's an old civilization that was able to make good soil somehow, kind of like the Mayans, but they were able, probably by burning something, mixing in organic matter, maybe dung or something like that. We don't know, but we found it in archaeological sites. But it's interesting that somebody thought it was that important that they had to do that, which we have not found elsewhere until basically the Industrial Revolution with crop rotations and all sorts of other things. Before that, people would put fish heads and waste and things like that in their soil. But they did create soil out of nothing and farm on that, which is kind of cool. They also did that in Central America, in Mexico, by making mats and reeds that they then grew off of. I suppose, let me say one thing, is that water plants, or hydroponic plants basically, also grew in Myanmar, Burma, Bangladesh, on these rafted areas where people lived in stilted huts and rafts there in Southeast Asia. But that is actually sucking energy out of the water, the nitrates, the phosphorus, potassium, that was the other one. I'm so sorry, guys. Potassium was the other one that Brighty Green is missing from its nutrient list. Iron and potassium and nitrogen. So it lets you dose things a little more accurately, but you it's not an all-in-one, and Easy Green you can probably get by using as an all-in-one. So I just want to talk about those two. That's Aquarium Co-op's brand, by the way, the Easy Green. So every second worldwide there's 150 lightning strikes. That's pretty cool, right? And lightning actually takes nitrogen and water, and it dissolves the two, basically, like fuses them, makes nitrites, and it then also takes the ATP that is in living teeny organisms, and it converts that into carbon, ripping things apart as it cracks through the sky and the oxygen. All of this can reform, be remade into ATP in bacteria, in plants, in fungi. And that very same ATP is used as energy and rearranged. Those parts that are needed by every single living thing, including you and me, are rearranged and reconstructed. And it's really beautiful. So I just wanted to kind of show you how the building blocks of what plants need for fertilization actually come in the Amazon, where we get things like angelfish, tetras, small dwarf cichlids, big fish like arapaima, things like that. All those fish and all the cool plants like sword plants and things like that, kabamba, mayaka, not kabamba Carolina, but red kabamba. So all those things, those plants that we use in our trade, lots of what's in my tank right here, fish and plants, are alive because of the Bodell Depression, which has phosphorus, which then picks up nitrogen and carbon, which causes hurricanes, which causes lightning, which causes rain, which causes water that plants need, which washes away too much of the nutrients in the Amazon, but brings just enough to leave a little bit left over in the Amazon. It's almost like it was meant to be. So, just wanted you to think about that. Think about what you are meant to be, what your aquarium is meant to be, and how you want to handle it. And take care of your little organisms. They are part of the biggest story on Earth. Take care of yourself. Like, subscribe if you want to see more. If you want to support this channel, more equipment, more stuff, more experiments, more traveling, more people, more interviews, please check me out on Patreon or check out my live streams. Alright, you guys. Take care. Have an excellent day. Use that ATP in your body. And I'll talk to you later. Peace.